Good day, everyone. This lesson is about ICT tools to develop problem-solving skills of students. I got the content of these slides or this presentation from different sources of on the internet. So the photo that you can see tells us about problem solving and digital technologies, wherein we can find different tools that we can use to assist us in learning mathematics or developing problem solving skills in our students. And this photo is from the link springer.com, and the link is given in this part. Okay, so we have classroom management and control. I guess that is Google Classroom. We have Wolfram, that is mathematical operations, graphic representation, and concept information. We have also tablets or mobile phones to keep on learning activities and communication activities. YouTube or Khan Academy, you can revise and extend content explanation and problem formulation. We have these different social media networks for communication and mathematical discussions. We have this, is this GeoGebra or Desmos? Okay, for dynamic representation and exploration, and we have Wikipedia for concept explanation. Okay, so these are the different tools presented here, but of course, developing problem-solving skills using digital technologies will not end with these tools alone. As teachers, we can explore, we can develop more skills, and also try different approaches using the different tools that we can find online. The presentation outline. So in this presentation, we have 6 parts that includes the first part, definitions and quotes about problem solving. Second part, principles for teaching problem solving. Third part, benefits of having a problem solving skills. And fourth part, problem solving frameworks. Fifth part, tools to support problem solving using problem-based learning. And sixth, additional resources. Also, I have included references on the last slide. Okay, this is from Problem Solving the Mark of an Independent Employee at from this link, and I retrieved this on June 24, 2021. It says, the ability to solve problems is an essential part of any employee's skill set, even if it isn't specified on the job description. That is why we need to develop our students' problem-solving ability or skills, because it is one of the most important skill set that any employee should have. This is from Problem Solving Skills Definitions and Examples, November 24, 2020, by Indeed editorial team. It says, some key problem-solving skills include active listening, analysis, research, creativity, communication, dependability, decision-making, team building. So these are the sub-skills or skills that are part of the whole problem-solving skill. Okay, so active listening, analysis, research, creativity, communication, dependability, decision-making, and team building. There are 5 primary steps in problem solving given by or from What Are Problem Solving Skills Definition and Examples of Problem Solving Skills by Alison Doyle. It was last updated October 21, 2020. It says that the first step is analyze the causes to the unwanted situation. So we can find a problem if there is an unwanted situation. Second, generate a set of alternative interventions to achieve your end goal. So a set of alternative interventions. You should be able to generate a set of alternative intervention. So if you have or you are initiating an event and then there is a sudden blackout, so what all the alternative interventions that you should do to achieve your end goal. Okay, number three, evaluate the best solution. So it's not only one intervention, but you should have many of them. And then you need to evaluate which of those has or is better to use. Number four, implement a plan. And number five, assess effectiveness. So this is, I believe, is a cycle if you have a problem. Okay, so if you can find out that effectiveness is not best, then you analyze again, you generate set of alternative interventions again, evaluate, implement, and assess again. Okay, so these are the five primary steps in problem solving based or by Addison Doyle. Doyle also said that problem-solving skills help you determine why an issue is happening and how to resolve that issue. It's one of the key skills that employers seek in job applicants. Problem-solving starts with identifying the issue, coming up with solutions, implementing those solutions, and evaluating their effectiveness. Since this is a skill that's important to most employers, put them front and center on your resume, cover letter, and in interviews. According to Henry Kaiser, problems are only opportunities in workflows. So, problems are opportunities. They are just clothed differently, but they are opportunities. Next, from what is problem solving? Having good, strong problem solving skills can make a huge difference to your career. According to Clerlin and Hervey 2019, how teachers organize classroom instruction is very much dependent on what they know and believe about mathematics and on what they understand about mathematics teaching and learning. Teachers need to recognize that problem-solving processes develop over time and are significantly improved by effective teaching practices. The teacher's role begins with selecting rich problem-solving tasks that focus on the mathematics the teacher wants their students to explore. A problem-solving approach is not only a way for developing students' thinking, but it also provides a context for learning mathematical concepts. Problem-solving allows students to transfer what they have already learned to unfamiliar situations. A problem-solving approach provides a way for students to actively construct their ideas about mathematics and to take responsibility for their learning. The challenge for mathematics teachers is to develop the students' mathematical thinking process alongside the knowledge and to create opportunities to present even routine mathematics tasks in problem-solving contexts. Continuation to continue, given the efforts today to include problem solving as an integral component of the mathematics curriculum and the limited implementation in classrooms, it will take more than rhetoric to achieve this goal. While providing valuable professional learning, resources, and more time are essential steps, it is possible that problem solving in mathematics will only become valued when high-stakes assessment reflects the importance of students solving of complex problems. So we really need to include assessment in our process of learning problem solving skills because we will not be able to evaluate how our students receive the instruction, understand it, and will be able to apply it without assessment. Principles for teaching problem solving. This is adapted from University of Waterloo Center for Teaching Excellence, teaching problem solving skills. Number one, model a useful problem-solving method. Number two, teach within a specific context. Number three, help students understand the problem. Number 4, take enough time. Ask questions and make suggestions. Number 6, link errors to misconceptions. Let's go over them one by one. Number 1, model a useful problem-solving method. Problem solving can be difficult and sometimes tedious. Show students by your example how to be patient and persistent and how to follow a structured method, such as Wood's model described in this presentation. Articulate your method as you use it so students see the connections. Next, teach within a specific context. Teach problem-solving skills in the context in which they will be used. Example, mole fraction calculations in a chemistry course. Use real-life problems in explanations, examples, and exams. Do not teach problem-solving as an independent, abstract skill. Number 3. Help students understand the problem. In order to solve problems, students need to define the end goal. This step is crucial to successful learning of problem-solving skills. If you succeed at helping students answer the questions what and why, finding the answer to how will be easier. Number 4, take enough time. When planning a lecture or tutorial, budget enough time for understanding the problem and defining the goal, both individually and as a class. Another that you need to have a time budget with is dealing with questions from you and your students. Another, making, finding, and fixing mistakes. And another one is solving entire problems in a single session. So when you plan to have a lecture or tutorial, your time should be divided into these 4 activities. Number 1, understanding the problem and defining the goal, both individually and as a class. Next, second, dealing with questions from you and your students. Third, making, finding, and fixing mistakes, and solving entire problems. So that is given a single session. So when you begin, you should have enough time for all of those activities. So that is number 4, take enough time. Number 5, ask questions and make suggestions. Ask students to predict what would happen if or explain why something happened. This will help them to develop analytical and deductive skills. Also, ask questions and make suggestions about strategies to encourage students to reflect on the problem-solving strategies that they use. Number 6 is link errors to misconceptions. Use errors as evidence of misconceptions, not carelessness or random guessing. Make an effort to isolate the misconception and correct it. Then teach students to do this by themselves. We can all learn from mistakes. So what are the benefits of having a problem-solving skills? If well facilitated, according to Dendane and Math 2009, if well facilitated, mathematical problem solving may help students develop and improve the generic ability to solve real-life problems, develop critical thinking skills and reasoning, gain deep understanding of concepts, work in groups, interact with, and help each other. Also, in mathematical problem solving, students can develop or understand concepts and facts, may it be in arithmetic, algebraic, geometric, or statistical, and so on. They can also have skills in different areas in mathematics like arithmetic, algebraic, geometry, manipulations, estimation, approximation, reading with understanding. They can also develop thinking and reasoning, whether inductively or deductively, and they can also use heuristics. They can have metacognition by analyzing and controlling one's thinking. They can develop attitudes of perseverance, having self-confidence, appreciate the power of problem solving. So if you have mathematical problem solving in your class, then you can develop students' attitudes like perseverance, self-confidence, and the appreciation of the power of problem solving. They can also use or they can also benefit from group work. Work in groups to overcome difficulties, solving challenging problems. Okay, so they will know how to develop team teamwork or how to be a team player. So these are the different mathematical problem solving um, benefits that your students can have. They can develop skills, they can develop their thinking and reasoning, they can understand concept and facts, they will be having or practice metacognition, they can develop their attitudes, and of course, they can play as a group or as a member of the group. So what are the different problem-solving frameworks? We have here Polya's problem-solving cycle. So in 1945, Polya developed his problem-solving cycle into 4 steps. First, understand the problem. Next, devise a plan, carry out the plan, and look back. So this is how Polya approached problem solving. So understand the problem, devise a plan, carry out the plan, and look back. The next is a problem-solving framework or model designed by Woods. And this is from Waterloo Center for Teaching Excellence. We have defined the problem, think about it, plan a solution, carry out the plan, look back. So if you notice, these are different frameworks designed by different people that they have commonalities and they look almost the same. However, there are different angles that make these models or frameworks differ from each other. So how to define the problem? Let's deal first Wood's problem-solving model. So to define the problem, the students or the teacher should have the system. Like have students identify the system under study a metal bridge subject to certain forces by interpreting the information provided in the problem statement. Drawing a diagram is a great way to do this. So there should be a system. Knowns and concepts. So list what is known about the problem and identify the knowledge needed to understand and eventually solve it. So these are ways how to define. Also, students should identify the unknowns. So once you have a list of knowns, identifying the unknowns becomes simpler. So one unknown is generally the answer to the problem, but there may be other unknowns. So be sure that students understand what they are expected to find. Also, while solving a problem, to define the problem, they should identify units and symbols. So one key aspect in problem solving is teaching students how to select, interpret, and use units and symbols. Emphasize the use of units whenever applicable. Develop a habit of using appropriate units and symbols yourself at all times. Yeah, that is also one of the problems when we neglect to put units or utilize symbols when we solve problems, because that is a practice that should be maintained with. And There is also a benefit why you should consider looking at the units, because sometimes a given number has minutes on it while the question is asking for how many seconds. So you should take note, or you should be able to help your students identify units and symbols. To define the problem, they need to identify constraints. All problems have some stated or implied constraints. Teach students to look for the words only, must, neglect, or assume to help identify the constraints. And lastly, they should identify criteria for success. Help students to consider from the beginning what a logical type of answer would be. What characteristic will it possess? For example, a quantitative problem will require an answer in some form of numerical units like dollar per kilogram product, square centimeter, etc. While an optimization problem requires an answer in the form of either a numerical maximum or minimum. So to define the problem, there should be a system, or the student should identify the system, identify the knowns and concepts. They should also be identifying unknowns, uh, also identify units and symbols, constraints, and criteria for success. The next step in Wood's problem-solving model is think about it. So to think about the problem, there are three things that students should do. Letter A, let it simmer. Use this stage to ponder the problem. Ideally, students will develop a mental image of the problem at hand during this stage. So, if you have experience while reading the problem, you are creating a mental picture about it. You are imagining, so if the sun is there and the tree is here, the shadow will fall, or it will cast a shadow like this. So even if you are just reading, or you are still reading the problem, you know what the picture would look like, and by that way you have initial understanding or solution in your mind already. So ponder upon the problem. Letter B, identify specific pieces of knowledge. So students need to determine by themselves the required background knowledge from illustrations, examples, and problems covered in the course. You should, or students should, identify specific pieces of knowledge. Letter C, collect information. Encourage students to collect pertinent information such as conversion factors, constants, and tables needed to solve the problem. So in this step, this is called about think about it. You should let it simmer, identify specific pieces of knowledge, and encourage students to collect information such as conversion factors, constants, and tables needed to solve the problem. The next level is plan a solution. To plan a solution, you should consider possible strategies. Often, the type of solution will be determined by the type of problem. Some common problem-solving strategies are compute, simplify, use an equation, make a model, diagram, table, or chart, or work backwards. And you can also, and after identifying, considering possible strategies, you choose which among those strategies is the best strategy to solve the problem at hand. Help students to choose the best strategy by reminding them again what they are required to find or calculate. The next step is carry out the plan. To carry out the plan, you should be patient and be persistent. Most problems are not solved quickly or on the first attempt. In other cases, executing the solution may be the easiest step. So be patient. Next is be persistent. If you carry out the plan, be persistent. If a plan does not work immediately, do not let students get discouraged. Encourage them to try a different strategy and keep trying. Sometimes I have the tendency to guide through the correct answer and not allowing them to be persistent. So you should be patient and be persistent. You should also teach your students to be patient and be persistent when dealing with problems. This also applies to the teacher who will be assisting the student or facilitating their learning. You should be patient. For some students can finish the problem right away, but others need more time than their classmates. So be patient, be persistent in teaching as well. The last step is look back. In this step, encourage students to reflect once a solution has been reached. Students should ask themselves the following questions. Does the answer make sense? That is really the first question. Tubag ba jud ni ako ang na-arrive na answer? Next, does it fit with the criteria established in step 1? Did I answer the question? What did I learn by doing this? Could I have done the problem another way? So this phase is very important. Reflection. This is part of the reflection. Looking back. Does the answer make sense? Does it fit with the criteria established? Did I answer the question? What did I learn by doing this? And could I have done the problem another way? So before presenting their final answer or their solution or product, every student should ask these questions to themselves in order to put meaning to what they were doing. Okay, so these are Wood's problem-solving model, or the steps in Wood's problem-solving model. Define the problem, think about it, plan a solution, carry out the plan, and look back. Another framework is adapted from Communication for Business Professionals, developed by Adler 1996. It shows the problem-solving process as a ladder in 7 steps. Number 1, define the problem. Number 2, analyze the problem. 3, establish criteria. 4, consider possible solutions. 5, decide on a solution. 6, implement the solution. And 7, follow up on the solution. So you can use this also to solve problem, this framework. So what is new here? Implement the solution, follow up. Instead of looking back or reflecting, you follow up what the solution give into the problem. Okay, next. This is also a problem-solving steps adapted from what is a problem-solving process from the Tech, GTS Tech, okay, .com. It is really a cycle. So first is you should analyze the problem, identify solution, choose solution, plan of action, implement, define problem, analyze, define, analyze, identify, choose, plan, implement. In this case, it doesn't have portion for reflection or looking back if the plan or have been effective. Maybe that is part of the implement. So this is another framework where you can use depending on the problem you are facing. Next is from Humor That Works. Problem solving framework. It is also a cycle, or it can be interconnected with each other. So define a problem is connected to brainstorm, pick a solution, implement, review. So define the problem is the first step. Brainstorm solutions, pick up a solution, implement, and review the result. So this is another framework that you can use depending on really the problem that you have at hand. So do you need to define the problem? Do you have someone to brainstorm with the solution? Which solution would you pick? and which solution would you implement, what will you do to implement the solution, and review the results. That means check if the solution really works, because if not, you need to start again or go back to another solutions. Diba? In step 2, you have brainstorm solution. That means you have many possible solutions and you pick only one. And so after you review the results and it was not good, then you can go back to brainstorming or defining the problem again. So that is how this model works, because it has arrows inside, or connectivity among the steps of the problem solving. Now let's proceed with the tools to support problem solving using problem-based learning. Problem-based learning can radically change students' learning. Rather than stuff students full of facts or material to memorize, problem-based learning encourages students to solve problems independently or in groups to find solutions. Additionally, problem-based learning is student-centered, which is where all education is headed. Robert Delisle explains, PBL asks students to demonstrate an understanding of the material, not just to parrot back information with a few word changes. Research and teachers' experience have demonstrated that active instructional techniques like PBL, problem-based learning, can motivate bored students and raise their understanding and achievement. Therefore, teachers must make efforts to provide students with problem-based learning activities. To grow your collection of PBL resources, here are 7 must-have apps and tools. So, why I choose problem-based learning as the basic to develop problem-solving skills? Because it is supported with research and teachers who have done this before. They have testified that problem-based learning offers a variety of ways in order to develop problem-solving skills of students. So this article is from 7 must-have problem-based learning apps, tools, and resources by Matthew Lynch on October 13, 2017 with this link. Let's start with number 1. Number 1 is EduCurious. Okay, what is EduCurious? It is a website with a supplemental apps that aim to turn students into developing experts by connecting them with real-world mentors. The site includes Common Core aligned curriculum that works to include 21st century technology, problem-based learning skills, and connections with experts. So that is how EduCurious work, and you can visit that in educurious.org. Number 2 is Newsella. Newsella is an incredible website that offers news articles from several major publications in several different reading levels. It works well with encouraging students to think critically and ask meaningful questions about the world around them. Plus, it features articles on all different subjects such as science, math, and history. So you can explore these websites, these apps. Usually, they are websites in order to learn from them, to learn what are the teachers are doing. You can access Newsella from newsella.com. Next is Padlet. So we have already, or we've been acquainted with Padlet. It is free, that's why. It has features for free users. So we can use Padlet. When students are engaged in collaborative work, Padlet is a great tool for the classroom. It works as an online bulletin board where students can post ideas, images, videos, and more. With problem-based learning, Padlet works as an excellent starting point where students can post research questions and post the answers they find as they research. So you can use Padlet depending on how will you utilize it in your classes and depending on the topic and the activities that you need to do with your students. The next is problem-based learning experience. So I have PBLE, problem-based learning experience, access from www.teacherswithapps.com. This unique app features a collection of starter questions to help students and teachers begin problem-based learning activities. Each starter question also contains a link to other resources to help students work to solve the problem in a real-world way. So, in Andy's classes for kindergarten, Teacher Sagan has this site where students can really answer and will know directly the result of their test or their supplemental activities, and it works. It can engage students, it will help students think, and they will look forward to doing it while at home or in their free time. So you can explore apps that are problem based so that you will allow your students to experience learning even if we are not in the classroom. They are not in the classroom. Next is Project Foundry. Project Foundry is a popular learning tool that enables students to plan their own learning and track their progress. It also makes organizing student projects much easier for students and teachers. Schools also love that Project Foundry gives students the chance to build digital portfolio, a necessary skill in today's evolving technological culture. So, project-based learning, according to this Foundry platform that grows as you do. You can make portfolio inside here. So you have solution resources about schedule a demo, contact. So I think this one is should be paid. Okay, because there is a scheduled demo and maybe they will be asking you some fees when you are using this. But if you happen to teach in a school where this is available, and then this is a best way also to develop problem solving skills with your students and in tracking how they improve as they learn using the e-portfolio feature of Project Foundry. Next is TED-Ed. TED-Ed is a fantastic resource for helping students gain insights into real-world problems. The site's collection of engaging videos works well to inspire students to learn more and take the initiative. Both are components necessary for problem-based learning. To want to learn more and to take the initiative. So you can use TED-Ed. Can discover, create, and support. And its logo says, stay curious. Students start here, education start here, parents start here. So it has features for all through um, for stakeholders of education, students, educators, and parents. You can access it in ed.ted.com. And then we have also the Knowledge Compass. The Knowledge Compass is a wonderful way to help students formulate questions and begin the research process. The website provides several different types of questions to help students ask the right questions to guide their research. So you can explore also the compass, the Knowledge Compass from www.knowledgecompass.org. So these are some tools to support problem solving using problem-based learning. You can explore them and you can use them as you teach, as you do your demonstration teaching, and as you prepare yourself to become teacher someday. So for additional resources, these are good sites for you to explore on digital tools to teach problem solving, tips for using exemplars problem solving procedure with students. So the link is here. Integrating ICT to mathematics. We have also the link here. ICT tools and 5 great ICT tools for teaching mathematics. If you have time, and I will not lock my course after the semester, because maybe someday you can go back to it and explore what are the resources that you can use when you teach. So here are the additional resources, and most of the quoted references is here. Then Dane A and Math UGRU 2009 April, and Clairlyn K and Hervey S 2019. So I hope you have learned something from this presentation. And class, once again, there are a lot of things that we can learn only if we will be curious about them. And then to utilize them, always believe in your capacity, creativity, and resourcefulness. Use your imagination and pray to God about it. God bless you and happy day.